Hello everyone, my name is Large. I work at CERN at the Accelerator Controls Group. I'm part of the DevOps team where I do Eclipse plugin development and support.
My name is Jed Anderson. I'm with Genuitec. I'm the Secure Delivery Center project manager. And I was an Eclipse committer in a past life and have continued on using the Eclipse community.
All right, so for those who don't know anything about CERN, I'm going to give you a very brief introduction. CERN is the world's largest particle physics research laboratory. Over 10,000 people work here, next to Geneva, on either side of the Swiss-French border. Our biggest installation is the Large Hadron Collider, or the LHC in short, which is a 27-kilometer long ring around 100 meters underground. Inside the LHC, particles get accelerated to nearly the speed of light and smashed against each other inside gigantic instruments called particle detectors. By analyzing the data coming out from these detectors, physicists are trying to improve our knowledge how our universe works. Well, you can ask, why are we talking about this? Because, yeah, we are not physicists, we are software developers. So we shouldn't care about this. But in fact, CERN employs 10 times more engineers and technicians than research physicists. Sure, if you go to CERN and you visit CERN, you will find a lot of physicists, but they are just the users of the system. They are not employed by CERN. Okay, the question is still on. Why do we need so many technical related guys? The answer is because we have huge installations what we have to build. This is one example for that. It's called the Atlas experiment, which is as big as a 5-story building and contains over 7,000 tons of sensors, electrical equipment, all sorts of stuff. Just to have this feeling how big it is, have a look on the man in the middle of the picture. That's how big it is. The LHC itself is also a huge engineering achievement. It consists of over 27 kilometers of superconducting magnets, which have to be cooled down to the temperature of minus 270 Celsius, which is, well, it's nowhere to be found in nature. So this is why we usually say that CERN is the coolest place in the universe. So we built this, we provided software to control its properties, and now, because it's working now, we have to maintain it in operation. I work at the Accelerator Controls Group, and our job is to provide the software that I just mentioned. On this picture, you can see our primary clients, the operators, in the control room. These are the people who actually maintain the operation. They are responsible for that. You can ask, how much software do we need to operate the machine? The answer is tons of. We have a lot of GUI applications running on the terminals in the control room, which is only the visible tip of the iceberg. We have a large 3-tier architecture with the GUIs on top, a middle-tier business infrastructure in the middle, and a low-level hardware access layer with embedded computers. Well, it sounds clear and easy to understand. But in fact, we have really complex systems. This visualization shows a small map about our middleware processes. Each node is a process, and each link is a network connection between these processes. So overall, we have hundreds of machines, we have thousands of processes, and we have millions of lines of code, mainly written in Java, but we also have some C++ code for the lower levels. And this is where Eclipse comes into picture. First of all, it's a very nice environment for Java and for C++ development. Plus, most of the technologies, mainly what we use, come with Eclipse tooling, so it's natural that we use it. On top of it, when we have requirements which there is no off-the-shelf solution, we can use it as a platform and we can extend it for our own needs. But we all know that Eclipse is really good, not to mention the community behind it. This is why I asked Jed to join us today, as he has big experience supporting many customers in their endeavors to use Eclipse efficiently.
Yeah, thanks, Ronald. So I got the chance to go to CERN as part of our ongoing support with them. And one of the things that really surprised me when I was there is how much this particle beam controls everyone's day-to-day life. It's really expensive to operate, and they lose a whole lot of money when it goes down. And it can go down just because you had a parameter that was slightly off and you lost the focus of the beam. So you've got all these parameters, over 100,000 parameters that need to be constantly adjusted. So it's very fragile. It's also very dangerous. In the particle beam, there's the energy of a TGV going 150 kilometers an hour. So this is really, really a lot of energy focused down to the smallest, smaller than any of us can conceive of, right? It's smaller than the eye of a needle. It's only a few microns across when the beams actually collide. So in order to maintain this beam, they need really good tools. And so they have looked to the Eclipse community and a lot of the code quality plugins that exist to give them a sense of how good is our code. Are we going to cause that beam to go down with a bug in our code? Additionally, it's one thing to install all these plugins, but if you've ever installed any one of them, you know there are lots of little knobs you can tweak, and so you need the right configuration for all those tools too. That's where our software comes in and deploys the tools on top of the Eclipse with all of the configuration necessary so that they can feel comfortable with their level of quality.
Okay, so now I'm going to show you a small visualization about how our SVR repository changes in 1 week. So what you see is that the white tree is the SVN source tree with all the branches, and the traveling nodes are the developers doing commits. So what you see is that people are not just focusing on one project and sticking to one place, rather they fly around like bees and they contribute into various projects and work independently, which suggests that we have a highly distributed environment and people work really independently, which is really true. We have a huge code base. We have 10 million lines of code for the accelerator control systems. We have over 1,000 jar files in production. And we have a lot of small teams who work independently, just knowing enough about the big picture to be able to work efficiently. So the coordination between these teams is done in an agile, informal way, which basically means that they coordinate along dependencies and stable APIs. So we have really special working environment, and to support these conditions, support our developers' work under these conditions, we provide some special tools. I'm going to show you 2 examples for that. So one is that, this one. This is a plugin which I wrote last year, which is a dependency analysis plugin. Basically, we can think about it as a server-client application, where the server takes all the binary files, binary jar files, from our binary repositories, parses it up with whiteboard analysis, and stores the structure and the dependencies in a relational database. The client side is an Eclipse plugin, where the developers can select one specific part of their code, and they can actually query who exactly is using this part amongst the 1,000 jar files. Another example is this tool for the hardware developers. With this, the hardware people can actually easily integrate their hardware into the middleware controls. So basically what happens is that the hardware developer defines all the properties for their hardware, and this tool generates all the code, all the boilerplate code, and the developer only has to fill out the parts where he gets and sets the property, a certain property for the hardware. So these are 2 examples how we actually use Eclipse as a platform where there is no off-the-shelf solution exists.
Another thing that struck me when I went to CERN was their staff. A large portion of their staff are actually short-term staff members. And so a lot of these people are students coming at the end of their studies to round out their education. And CERN wants to make good use of these really bright people. And so they need a way to make them effective. And choosing Eclipse as the base IDE for the organization made a whole lot of sense, because that's what a lot of students were seeing or were already exposed to in their studies. Another thing that you have to think about is, do you have the right tools to get these people up and running right away? It's one thing to sit down at a desk on your first day and spend 3 days getting your environment ready. It's another thing if your tool just does that for you and you're up and coding. Also, Donut is almost alone. He's got one colleague, and the 2 of them have to support 200 people, more than 200 people. And so with a really small support staff like that, you have to be very efficient in how you provide support. But at the same time, they want to provide really amazing support. So when Donut gets a support ticket from somebody, he actually gets up out of his chair and goes over to their desk and says, "What's wrong? How can we help?"
Yeah, so we have really limited resources, like really the two of us actually are doing it. And we have a lot of customers. We have over 200 developers. So to support our people, to support these people, there is just one natural way to go, and is that we create one Eclipse distribution, as we support that one, and we customize that one. So what we do, we create one package, we give it to the users along with all the customizations, so they don't have to deal with setup. They can start working with minimal setup time, and we still can give excellent support. On the other hand, we have to deal with the fact that our developers are really inventive. They are constantly finding new tools, they are finding new configurations, and also they expect us to listen to their feedback and integrate their invention. So we really have to be flexible in the standardization process in order to keep them happy.
So as Donut said, they're going to dictate a tool stack for their developers. They're going to say, either you're with us and we'll give you awesome support, or you can go do it on your own and you can answer to your team lead as to why it's taking you so long to fix that bug, because you're spending all that time setting up your environment. But then when they're really bright individuals come back and say, hey, I need a new tool, you have to be able to provide that flexibility. And so it's this give and take, right? You need to dictate, but you also need to be flexible. You need to use the tools to push out the updates, because you can't rely in this sort of environment, you can't rely on people following those instructions, right? You have to say everybody gets the same code, because we cannot have the beam, need to be shut down. And so then you need to be respectful of the developers and their choices, the stuff that they can, tweak, a color in your Eclipse editor. You shouldn't be dictating that, right? Let the developer decide how they want to look at their code. So in all, it's kind of a benevolent dictatorship. Giving people what they need and realizing that you can give it to them in a better way than they can do it themselves, or at least in a more efficient way.
Yeah, so we started working on our custom-made Eclipse distribution around a year ago. And when we started, we thought, well, it cannot be that hard to create our own Eclipse distribution. That's basically what it is. You just take a vanilla distribution, we put all of our customization, all of our plugins in it, zip it, put it on a website, problem solved. And in fact, we tried. We spent 6 weeks creating all these packages, what we needed, created some update sites. But after 6 weeks, we found even more problems than the things which we could solve. And what was so hard? The problem came from the fact that we have a lot of requirements. First of all, we were looking for flexibility. So we didn't want just put a distribution to a read-only file system and saying, guys, here's an NFS folder, take it and use Eclipse like you cannot modify anything. Because at the end, we wanted to create the same user experience as anybody would get if they download Eclipse from eclipse.org and they use it the same way. The second thing is that we wanted to have everybody in a consistent environment. We have a lot of people using different platforms. Some people work on Linux, some people work on Windows, 32-bit, 64-bit machines. So already this is like 4 packages for the people. Another thing is that we had to provide update sites since our developers were behind a firewall. So it was not easy at all to take all the update sites from outside, mirror them and put it inside the firewall. And also, the biggest issue was that we are not looking for just consistency at the beginning and setup time. We are looking for consistency over time. So if we had a modification in the preferences, we had an update for a certain plugin, it was not enough to just put it on an update site, because it would leave the developers open the fact that, okay, they can click on the updates, check for updates, and people usually, they don't do it. And The thing is, we were looking for this because we wanted to provide some supportability for the people. Because if you know that if everybody is more or less in the same environment, and they send us an email, okay, my Eclipse is not working, then we don't have to deal with the environmental factor. We know what's happening, we know what's installed for the people's environment, and we can effectively, efficiently debug their problem.
So let's look at some real-world examples. Some of these are a little silly, but they actually happened at CERN, right? Somebody said, this plugin isn't working, and when Donut went over to the guy's desk, he was still running Eclipse 3.4. So there was no accountability in terms of what tool stack you're using. Also, the architecture mismatch problem is one that we see in the industry over and over and over again. People are just confused about what you have to have in order to use the 64-bit version of Eclipse. You need the 64-bit platform underneath, you need the 64-bit OS, the 64-bit JVM, and the 64-bit Eclipse. And if you don't have all of that, then you can't run the 64-bit version of Eclipse. Also, finding the right versions of plugins can be hard. For example, CERN had an SVN client on the command line that produced different metadata than the SVN client inside of Eclipse. And so this was causing merge conflicts and things like that. So one of the solutions was to ship the client, the command line client, as well as the Eclipse plugin, all in one bundle. Also, we've all seen this diagram, or this dialogue of I'm trying to install a new version and it requires plugin XYZ of version 5, and that conflicts with this other plugin that requires version 4, and they both can't be installed. Solving these things is not rocket science. I mean, you can track down what needs to happen in order for the software to be installed next to each other. However, it is time consuming, and you don't want to lose that time across your entire team. If everyone has to learn the solution to the problem, it's a big detriment in terms of your schedule. Also, update sites come and go, and this is something that we see over and over and over. Not only do they come and go, but people don't feel the need to keep them up to date or to leave old versions around. You'd be surprised how many people are out there who want the old version of your software, not the new version. And so, because people don't think about that, you have this requirement on update sites that you didn't know you have. And so, like Donut said, they started mirroring in update sites, and that's an excellent policy. So once you've got the right Eclipse and the right plugins installed, then you have to make sure it's configured right. And I alluded to this earlier, but you want to make sure that all the preferences are consistent across your entire team so that you know everyone's compiling with the same compiler settings. They are having, for example, the Gradle plugin is using the same settings. Also, sometimes, like with Gradle, you have to configure the location where Gradle is installed on your system. And you are the one who knows that, right? You're the systems administrator, so you know Gradle's installed here, and so we want to make sure that that preference is set up correctly so that the users can start using Gradle right out of the box. A note about plugin misconfiguration is that a lot of plugins don't use the Eclipse API for preferences. And so when you're thinking about, I'm going to ship a unified development environment, you have to consider what happens when you encounter a plugin that isn't going to use an EPF file format for exchanging its plugins. And finally, they're behind the firewall, and they cannot phone home, right? And they don't even want those requests happening, so they have to go through and determine which plugins are going to try and phone home, and turn all those phone home features off, so that when the Eclipse starts up, you don't get the SVN dialog, things like that. Another interesting use case is that because they have all these students who don't know about the tool set that exists already in CERN, they wanted the first experience these students would have would be a perspective with those views that CERN has written, so that there would just be a little bit of awareness of those custom tools. And so you can go beyond just setting up preferences, you can actually set up the workbench as well. So all in all, your development environment is not just Eclipse, right? There's a lot more here. that you have to think about. And some of you might be doing embedded programming. You have to think about device drivers or shipping extra compilers, things like that. So it's about bundling all of that together and making a consistent IDE for your developers. Once you've made the consistent IDE, like Donat said, you need that consistency over time. And so there's always the guy who's saying, oh, I'll take the next update. My work is too important right now. I can't have you messing with my Eclipse. Also, when a new version of Eclipse comes out, everybody deletes their old version and installs the new version. This shouldn't be necessary. And in fact, this is one of the key features, I think, of our software, is that when the new version of Eclipse comes out, you just do an update, and you now have the new version of Kepler, or whatever the next release is you want to move to. Also, especially in CERN, but across a lot of industries, you need to enforce your updates and say, look, we're doing this for your own good, it's so we don't put any bugs in the code, right? And so you say, I'm going to make sure that you guys take the updates. And then finally, you want to be able to allow some rolling back. If you have teams that need to support older versions of software, you also need to think about that problem. So one final example that I really like, CERN recently migrated their SVN repository from one place to another. Now they could have written some documentation saying, okay team, read the documentation, follow the instructions, everybody become an expert in disconnecting your SVN repository and reconnecting it. Or you could solve it with a tool. And so what they did is they put out a notification saying, we're going to migrate, everybody heads up. And then they also put out a plugin that added a menu item that did that migration for the users automatically. So this is an excellent example of like, you can accelerate your development just by providing the right tools. And then at the end, when they were done with it, they just removed it from the IDE and it didn't need to be there anymore. So how do you scale? You can do it over via staffing. This is one option. You need a lot of staff members because the matrix of packages that you're going to start creating gets really, really large. So our solution is use the tools that will make it easier for you to ship Eclipse. And then start by packaging everything in one bundle. And then over time you can start to expand that and add more plugins, add a secondary bundle, add that bundle for the team that's just doing mobile development, things like that. Finally, collaborate with your developers. I don't think we can stress this enough. It's really, really important that you talk to your developers about what software they need and is the tool stack that you're providing them right now appropriate for their needs.
Right, so we have enough time to do this, show this few examples, what kind of software do we actually develop at CERN. So for instance, this is called technical infrastructure monitoring, and if you visit CERN and you see it in a lot of screens in the control room, this is a tool where with the operators actually can check the current state of the accelerator. The interesting fact about this tool is that it's not just a static finite set of static views about the control system, it's rather the toolbox where the operators can assemble their views which they can use to monitor the status for the LHC effectively. The second application is called fixed displays, and if you visit CERN, and I strongly suggest to do that, you will find this application running on screens all around the place. So basically with this, the responsible can see the current state for the accelerator at any time, even during, for instance, lunch at the restaurant. So if he sees there is a problem, he can just drop his knife and fork and he rush back to his office and he can fix the problem. Our third and last example would be this one, called the sequencer, which basically is a driver set for the LHC. It defines all the steps which is necessary to start up the LHC from the beginning till the end, when there is a thing called physics mode, where actually the LHC turns into the state where the physicists can do their science, basically. Here, there is one interesting fact, is that the UI is implemented with SWT and JFace, just to have these fancy features which was not available before. This application was developed like 7-8 years ago, so it was pretty neat at the time. Okay, so we are at the end. So to give you a short summary, I would like to sum the things up to show how it was possible to scale up Eclipse to the CERN level. First, you have to invest in centralized tooling support. One option, to let all the developers spend 5% of his time setting up and maintaining his environment. But in a huge organization, large organization, just like CERN, it's much more efficient to have a small support team who takes care about the tools and the support with it. Second, be a benevolent dictator. We have a message to our developers. You are either with us, you use our tools, and you get excellent support, or you are on your own. We standardize on one tool stack, and reinforce our updates, basically once a week. That's it. We are really flexible on the standardization process, and we listen to our developers within our resources. The last thing is use tools over documentation. If the entire customization and the update process is done automatically, then it's much easier to maintain a working, consistent environment for everybody. Developers should be able to modify the preferences just like at any time, but the best tools are the ones which just work out of the box.
So before we finish, I'd just like to point out we have a couple more talks upcoming this week. There's a BOF tomorrow night where we're going to have a panel of Eclipse delivery experts, and you can come and bring your questions. And then my colleague is also doing a talk, Tales from the Crypt, the must-knows to ship software to enterprises. That's on Thursday. Stop by our booth. We are giving away a AR drone. Are there any questions? Yes?
I was curious to know of the users of the software, developers, are they almost all or all their primary profile is scientist and developer secondary, or do they all have approximately the same profile, or do they have different profiles?
Basically, the tools are developed for the people who take care about the tools. So basically, they are technicians, but also some of the tools are for the physicists who also want to contribute in the maintenance process. But basically, the majority is for the technicians who are monitoring the current state. They are fine adjusting the properties for the LHC.
Okay, thank you very much.
Thank you very much.